Good morning. Once again, I welcome to the part 2 of engineering mechanics. And in this topic also, we are going to discuss under the resolution of forces and resultant of several concurrent forces. So, in this topic, we will be discussing few derivations given by the theorems. We'll be undergoing some different theorems. We'll be solving it, and later, based on this theorem, we are going to solve a problem, and that will be the total content of this session. Okay, now let us go to the topic. So now let us go to this Lamy's theorem. So Lamy's theorem is nothing but it states that if three coplanar forces acting at a point B in equilibrium, then each force is proportional to the sine of the angle between the other two. So this is the given theorem by the Lamy's. For example, in any forces, for example, if any forces acting at a point, maybe 3, for example, let us say it's a 3. If any 3 forces are acting either towards the static body or away from its static body, then it is very easy for us to get the resultant force by applying this Lamy's theorem. So this condition lies only for the forces if only 3 forces are acting. If it is more than 3 or less than 3, this formula may not be applicable. Okay, so that is why the Lamy's has found out this one. So mathematically, he has given this derivation as they have given the formula as P by sine alpha is equal to Q by sine beta is equal to S by sine gamma. So let us see. Let us start with how we can derive how this formula is derived, and later based on that we are going to see a problem. Okay, fine. Now let us see. Let us consider a 3 coplanar concurrent forces P, Q and S acting at O. As I told you already, and 3 forces are acting in a single point with respect to its concurrent angles like alpha, beta and gamma. So let us take an example of this diagram like what you're seeing on the screen. At point O, some 3 forces are acting away from point O with respect to its angle alpha, beta and gamma. Now here comes the solution. Okay, now from the geometry of this diagram, what you're seeing on the screen, in this geometry is nothing but from the 3 forces, if you just draw similar parallel lines either extending from A to C or B to C, where it intersects, that is these two parallels, AC should be parallel to OB, and you should draw a line parallel to AO, that is BC. So this intersecting point of these two lines AC and BC will be at point C, where if you draw a perpendicular line from point O, then it intersects at point C. So taking this one into consideration, into mind, now let us see how to slowly derive this formula. So now by this diagram, it's very easily understood that it has formed some 2 triangles. One is OAC as well as the other triangle as OBC. Okay, right. Now let us take this one angle from this triangle. That it is very easy to identify that angle AOC will be equal to 180 minus beta. So what is that 180 minus beta? It's very easily AOC will be 180 minus beta. Okay, fine. I think you know that because by the diagram we can understand. Similarly, BOC is equal to 180 minus alpha, and similarly angle AOC will be equal to angle BOC. That is obvious, and that will be equal to 180 minus alpha. Right? Now, we know that the sum of the interior angles will be equal to 180 degree. So that also by the trigonometric law, you know that. So that is why we can directly take it as in triangle AOC. In triangle AOC, OC will be the hypotenuse side, and AC and AO will be adjacent and opposite side respectively. Now let us take this one. Angle AOC plus angle ACO plus angle CAO will be equal to 180 degree. That you know very well, right? Now from here, from this, angle CAO is equal to 180 minus angle AOC minus plus angle ACO. So that simple arithmetic means a trigonometric method which you are going to just bring it from left to right. That's all. So if you do that, already you have found out what the value of angle AOC and angle ACO. By substituting these two values here in between that, you will get a solution as angle CAO will be equal to alpha plus beta minus 180 degree. Hope you understood. And similarly, we know that alpha plus beta plus gamma will give a total angle. It's a complete circle. I mean, if you take it as, then it gives us 360 degree. From there, if you subtract 180 from the either side, then alpha plus beta plus gamma minus 180 will become 360 minus 180. So if you understand very clearly, then by this you can take it as alpha plus beta minus 180 plus gamma is equal to 180. Let us see how it has come here. Already if you know that alpha plus beta minus 180 has come out, and then that will become 0, and ultimately for other side also will become 180. And finally, you'll get the answer as angle CAO gives the alpha plus beta minus 180. And so that is nothing but the angle CAO can be taken as 180 minus gamma. Okay. Now applying the sine rule of the triangle. What is the sine rule? Sine rule is nothing but opposite by hypotenuse, adjacent by hypotenuse. So this you have studied in the lower class also. So similarly, by applying the sine rule, we can very easily understand that opposite is OA and hypotenuse side is sine angle ACO. Similarly, AC by sine angle AOC and is equal to OC by sine angle OAC. So by this, you know that ACO, what's the value of ACO, AOC as well as OAC. Very easily understood that is 180 minus alpha, 180 minus beta, and 180 minus gamma. So that can be written as P by sine alpha, that is equal to Q by sine beta, and that is equal to S by sine gamma. So this is the method of deriving this problem, and you have arrived this formula. Later, based on this formula, let us solve a problem. Okay. Now let us take an example. An electric fixture, light fixture weighing 150 newtons hangs from a point C by two strings and AC, BC as shown in the figure. Determine the forces in the strings AC and BC. Now let us take an example. Here this will be the diagram which is given along with the question, and very clearly it is shown that the angle 60 with respect to its vertical wall and 45 with respect to its ceiling. So here AC and BC are the two strings which is tied towards the ceiling and the wall, which makes an angle respectively as shown in the figure, and the weight is hanging for about 150 Newton as a light. So this is the condition given. So ultimately we know after deriving this formula, you can arrive to that some three forces are acting at points from point C, maybe 150 Newton, CA tension at CA, also TCA, as well as tension on the wire BC. We can take it as TBC. So when you do like this, it's very easy for you to calculate all the other three angles by the diagram. It's very clearly understood now after drawing a free body diagram. Very easily, if you draw a horizontal line passing through C and a vertical line passing through C, very easily it makes a right angle, and the remaining angle will be calculated by the trigonometric method, and the angle between TCB, C and 150 Newton will be taken as 120, and the angle between TCA, C and 150 Newton will be taken as 135. So now later the remaining angle TCB, TCA is available. How will you find out? It's very easy that the total angle is 360. So 360 minus the sum of 120 and 135 will give the angle of TCB, C and TCA. So that's where you have found all the three angles, and you will get the solution like this. TCB divided by sine 135 and TCA divided by sine 120 and is equal to 150 divided by sine 105. Okay, so by equating these three, it's very easy to find out all the two unknown values, which is TCB and TCA, by equating any two equations. For example, the 1 and 3. If you take TCB divided by sine 135 is equal to 150 divided by sine 105, that will give the cross multiplication will give the value of TCB, and that will be taken as 109.81 Newton. So if you have a practice, you try to use your calculator and find the solution. Similarly, taking the other equation like TCA and 150, so you will get this value as TCA and the solution will be like the answer which is given as 134.49. So now by seeing this within a single step, it's very easy for us to resolve and get the solution of TCB, tension of TCB as well as tension of TCA. Instead of taking sigma H, sigma B, finding out the resultant, all these stories, nothing is required. Directly we can find out this method. So this is found out by this Lamy's, and hence we are calling this one as an Lamy's theorem, applying the Lamy's theorem. Now let us go to the one more equation which is called as an Parallelogram Law of Forces. It states that if two forces acting simultaneously at a point be represented in magnitude and direction by the two adjacent sides of a parallelogram, then the resultant of two forces is represented in magnitude and the direction by the diagonal of that parallelogram originating from the point. Maybe a little bit confusing because it's a lengthier one. And let us go to the proof like what you're seeing now. So according to this definition, let me draw a diagram like what you're seeing on the screen. Here from point O, OP is the force acting and OQ is the force acting. Right. So if two forces are acting here, then the next step what you have to do is you have to draw a parallel line BC which is parallel to, if you were to draw a line, extend the line BC parallel to OD. Similarly, you have to draw one more line DC parallel to OB. So that is what is shown on the diagram. And if you draw a center line, that is OC passing through that, that will be the resultant force acting along that line, along the line OC. So that is clearly represented in that diagram. By this, very easily we can say that OB will be equal to AC because it is parallel, and BC will be equal to OA. Now if you extend that line and draw a perpendicular line, then which meets at point C and D. Okay, so that is what you have to develop that, and all the angle theta and D is given by seeing the diagram. Now let us see step by step procedure how to proceed this. Okay, now we can see in triangle ACD. Let us consider the triangle ACD. In triangular ACD is nothing but the angle theta is shown like what is there, and AC is the hypotenuse side, and AD and DC are adjacent and opposite side. Okay, fine. In triangle ACD, now let us say that cos theta is equal to opposite by adjacent by hypotenuse. That is why I have given it as an AD by Q. Similarly, sin theta will be equal to, what is that? Opposite by hypotenuse, that is DC divided by Q. That we can see later. Now we can see AD is equal to Q cos theta, and now sin theta is equal to CD by Q as I told you, and CD is equal to Q sin theta, and these are the two equations which you have to take from the triangle ADC. Hope you students are understanding what I am saying. And now let us move to the triangle. So the triangle which is shown on that, I have taken it separately like O, A, D and C, that separate triangle here because DC is a perpendicular line. R is the resultant force line passing through, the resultant force passing through OC. Now it's very clear that the distance of OD will be taken as OA plus AD. I think you can understand that. And by this, you can just take this one by the trigonometric method. It's very easily understood that OC squared is equal to, or normally in a triangle you say that the hypotenuse side will be equal to the square of opposite and adjacent. Okay, so that is what it is given. So OC squared is equal to OD squared plus CD squared. But in case of OD, you know well that is that OA plus AD. So that you have to substitute this value in the place of OD and write it as OA plus AD whole square. So now by the trigonometric method, A plus B whole square formula, that is A square plus B square plus 2AB, by using that formula, we have to split that by applying that, and then you will get the solution like what you're seeing on the screen. Okay, right. So after doing this, finally, you will get the solution as R squared is equal to OC squared is equal to R squared, OA squared is equal to P squared, and similarly everything will be coming like that, P squared plus Q squared plus 2PQ cos theta. So all this you have got. Understand? So that by this you have to calculate like this, and R will be given as the root of R is taken, the root we have breaken to the right hand side, and that will be the equation given as root of P squared plus Q squared plus 2PQ cos theta. Hope you understood. So up till this is enough for finding out the parallelogram law of forces. And similarly from that triangle, one more thing is that you have to find out some other value also. So let us take that in the triangle OCD. In the previous diagram, whatever you have seen that here in triangle OCD, imagine here, okay, I have given the diagram here itself. Okay, now in OCD, tan alpha is equal to opposite by adjacent, that is CD by OD. So by that you can get that solution as Q sin theta divided by P plus Q cos theta. So this also you know. By this trigonometric method we have taken like this. And tan beta is equal to P sin theta divided by Q plus P cos theta. That also you can take it very easily with respect to the angle beta. In the other triangle, if you see the original triangle, you can see that from there I have taken it. Then from there we can take an example. So this is a formula. We have to just take into account the tan alpha and tan beta, and let us go to the problem which is similar to that, which can solve it now. So the problem is given as two forces of magnitude 10 Newton and 8 Newton are acting at a point, and if the angle between the two forces is 60 degree, determine the magnitude of the resultant force. So what they have given is, they have given the value a 10 Newton, 8 Newton, as well as the angle between the two forces is 60 degree. So by using your parallelogram law of force, the formula, very easily we can solve this problem. Let us see what is given now. The given is P as 10 Newton and Q as 8 Newton, which is given in the question itself. And the angle between these two forces are 60 degree. That is also given. So by applying this formula, that is R is equal to root of P squared plus Q squared plus 2PQ cos theta, which we have derived. So P value is known, Q value is known. At the same time, theta is also given as 60 degree. So directly we can use your calculator and find out the value of R as like what you're seeing in the screen, substituting. Then you will get the answer as 15.6205 Newton. So this is the way of calculating the resultant force if such a problem is given. Understand? Now let us go to the next topic, which is free body diagram. What is free body diagram? Free body diagram is nothing but, once again, if any force is acting on a static body or even at a motion, so with respect to that you have to draw a free body diagram, which makes you easy. From that we have to take all the resolution of forces, and then you have to calculate. So that is what we are going to see now. For example, a body or a cylinder or a sphere is just resting on a ground, on a horizontal ground. You can see on the screen it is resting on a horizontal ground. So when it is resting on a horizontal ground, you cannot take directly that you cannot assume that simply it is resting on the ground. No, not like that. There is some resistance for me, and it is just placed on the ground. Either you take an object, either the human, either the vehicle, whatever is moving on this ground or available or above this ground, above this earth, everything has its own gravitational force at the same time and the reaction force. Even if you stand on a plain ground, if you are standing on a horizontal ground without touching anything, then exactly whatever with respect to the load acting on your body, suppose if you are 50 kgs, and there will be a reaction force acting in the opposite direction on the ground, from the ground, in order to make you to stand exactly on the ground with respect to its center of gravity. So that is what it is happening. It is shown on the diagram. Let us take a sphere of certain weight W. With respect to its weight, it is just resting on the ground. Okay, it is resting on a horizontal ground. That is what is shown in the diagram. So weight is acting towards the downward direction, perpendicularly downwards, and with respect to this, from the ground, there will be some resistant force acting in the opposite direction. So that is given by R, and resistant force R will be acting in the opposite direction. Hope you can understand the concept very clearly. Now for this, you are going to take everywhere, whenever the body is coming in contact with any other part, either the ceiling or a wall or even the ground, at every place, wherever you are just having in contact, in that place, you have to draw a reaction force. That is the story of this one. Now for this, let us take few examples like what you're seeing on the screen. 1 and 2, new different conditions are given here. On this condition, if you take a first one, if you see that the body is freely suspended in table 1, if you see that a sphere is just tied with a rope AB or a string AB, and it is suspended from a wall, from a vertical wall. Okay, it is suspended from a vertical wall. What did I say now? Whenever a body is coming in contact with a wall or ceiling or a ground, there will be a reaction force opposite to that point where it is coming in contact with that wall. So here in this case, at point C, it is the sphere is coming in contact. So there will be, suppose imagine if the vertical wall is not available, what happens now? From the top, it will be suspended. The sphere will be suspended, only vertically downward force will be acting, no horizontal forces will be acting here. Since there some resistance is given by the wall, so ultimately the reaction force RC will be taking in the opposite direction, and the tension in the string AB will be given as TBA, and the weight with respect to its ground direction, that is perpendicularly downward direction. So that is called as an free body diagram. So now similarly for all the objects, either 2, 3, 4, 5, 6, 7, and many things are given different conditions. For all these conditions, with respect to that, the free body diagram is shown. How to draw a free body diagram for the condition given below. So these are all the conditions which is given to you now. Based on this, we are going to solve the problem and then see the solution. Okay, now shall we move to the problem? Okay, fine. Let us take a question here. Very simple question, like a sphere is suspended from a ceiling which is tied by the rope AO by a string. Okay, right. B is the point which is coming in contact. Its free body diagram will be drawn like what you're seeing on the screen. Okay, free body diagram is the reaction force, as I told you. RB is there, W is there, and TCA is there. Okay, fine. Now in this condition, it is very easily understood that OB is nothing but is equal to OC is equal to the radius R. AC is equal to R. How we are saying AC is equal to R is nothing but AC is equal to R is nothing but the string AO, which is tied with that, is twice the radius, that's all. So by that we can very easily identify that AC is equal to R and weight is given as W. So OA is equal to OC plus CA. So R plus R, that is equal to 2R. So that is what I told you. And then OB is equal to R, that is also R, because the radius of the sphere. Okay. Now we can see how to calculate this. Cos theta is equal to OB by opposite by hypotenuse. Sorry, adjacent by hypotenuse. So OB by AO. So what is value of OB? OB is R and AO is 2R. So 2R by R will be given as, say R by 2R will be given as 1 by 2. So cos theta is equal to 1 by 2. Theta is equal to cos inverse of that value. That gives the angle 60. So angle OAB will be angle 60. Okay. AOB will be angle, theta will be angle 60. Okay, fine. After finding out, since there are only three forces, we can use very easily. If you are smart enough, you can use this, the Lamy's theorem, which is shown on the screen now. By using these formulas, we can substitute the values and get the unknown values very easily. That is, unknown values TCA as well as RB. Understand? So by substituting this, we can get the values. First of all, you have to find out this and find out this TCA, RA, and from that you have to apply this Lamy's theorem. And by applying this Lamy's theorem, very easily we can get the unknown values of TCA, and TCA is given as W, and once again you will get an RB also, you will get it. You will get the value here in terms of W, and then equating these two, equation 1 and 2, very easily we can get the value. Or otherwise, if the weight is not weight is an unknown, leave it as it is and just write the value of TCA and RB. That much is enough. That gives a solution of this problem. This is an example I have told you. And now let us go to the next condition. Let us see how the system works in this problem. Okay. Now I have gone for a little bit tough, which you have to learn now. Okay. So the tough is nothing but two identical rollers, each of weight 50 Newton, and all the inclined plane on a vertical as shown in the figure, and the reactions at the points of support A and B, ABC, assume that the surfaces are to be smooth. Now the diagram which is given on the screen as two identical rollers. Keep in mind that always if two identical rollers are given, it means that with respect to its weight, the diameter, everything will be same. Understand? So that is what we are calling it as two identical rollers. So let us see the diameter. As I told you, a diameter is given, or the diameter is not given in this diagram. Okay. Now let us see how to calculate that one. Okay. Okay. Fine. Here, this will be your free body diagram for each roller. If you find the roller 2 and 1, in case of, see, as I told you, wherever it is coming in contact, there will be a reaction force acting in this opposite direction. So by that law, whatever you have understood, very easily we can see the reaction force with respect to point C is given as RC, and the reaction force perpendicular to that slope is given as RB for the spherical, rollers, cylinder roller 1, and vertically perpendicular downwards, W will be acting downward direction 50 Newton, and one more contact point is with the roller 2. So there also one opposite reaction FED will be acting here, that is in the opposite direction. And similarly, when you take the second roller, in that roller also the weight is acting perpendicular to that, and which is coming on the slope, coming in contact. RA will be the perpendicular reaction force acting at the point A, and an opposite reaction force acting exactly opposite to that from the cylinder 1, from the sphere 1, that is FDE will be acting. Now let us see how to solve the problem. Once if you know to draw the free body diagram correctly, then it is very easy for us to solve the problem. Now let us see how to solve the problem. Now before solving the problem, the first step what you have to take is, in whatever the problem is given, how many number of forces are acting in a particular point, that you should notice. Your main aim is to find out how many forces are acting in a particular body. So if you take that, you have to start with solving a problem from the sphere, how many number of forces, very minimum number of forces are acting in a particular body, maybe a cylinder 1 or 2, whatever it is in this case. So here in this case, whatever you see, from cylinder 1, there are four forces acting here. So ultimately it is higher than the previous one. So if we take the second cylinder, only 3 forces are acting. So it is obvious that you have to start solving a problem from cylinder 2. Okay, now let us see this example. If you take cylinder 2, the free body diagram is given in the screen, what you're seeing here. Okay, in that, now if you see, the angle with respect to the slope is given as 30. So from there, if you drew your trigonometric diagram, also drawing perpendicular line to that inclined angle, and you will get an angle 60, because since the opposite, when you draw a perpendicular line, it is 90, and if you know very well that a triangular inner angle will be 180 degree, by that you are getting the angle 60. So from there it starts, and you can find out you can take this adjacent angle, opposite angles, and then find out these values as 30 and 60 degree, like what you're seeing on the screen. Okay. Now after this, if 3 forces are acting, either you can use the Lamy's theorem, or you can resolve it by sigma h and sigma v. Okay, fine. In this case, let us go to find out the sigma h and sigma v itself, because there are some 2 unknowns are available. When you are resolving that, you will get some unknown value itself. Then if you go to the cylinder 2 only, we can find out the other solution. That is what you are going to see now. Now taking horizontally sigma h value, so you will get that like what you're seeing on the screen is FDE cos 30 minus RA cos 60 is equal to 0. So that is one equation when you resolve it with respect to its horizontal values. Now if you take the vertical values, similarly FD is sin 30 is equal to RA sin 60 minus 50, that is equal to 0. So I have got two equations. If you notice in these two equations, either FDE as well as RA is common. FDE as well as RA is common. So you can eradicate any one equation, any one value, unknown value by equating 1 and 2, and we can get the solution one by one. So that is what you are going to see here. Solving the equation 1 and 2, and it can be determined like FDE is equal, cos 30 is equal to RA cos 60. Do you know how you got it? The previous equation, FDE and FDE cos 30 and FDE cos 30 is equal to RA cos 60. Okay, so that is what it is given now. And similarly, FDE is equal to RA cos 60 divided by cos 30. That will be giving us in the form of RA value itself. So you know very clearly that FD is equal to 0.577 RA. So this value can be introduced or substituted in any one equation by eradicating the FDE, and we can get the value of RA. So that is what you are going to do it here by substituting in equation 2. So RA becomes common here, only RA is unknown. So by using this simple calculation, that is an arithmetic calculation, we can find out the value of RA, and RA will be right as 25 Newton. Sorry, FD will be as 25 Newton, and taking the next roller, so that much is enough. Okay, so FD value I got it, and you can just use this one. You go to the diagram for the first roller, and if you take the free body diagram for the first roller, this will be your free body diagram, and already you know very well that both the opposite directions, since both the cylinders are identical, FD value will be equal to FED. So directly we have got this value, and you need not to calculate separately, and you can write the value as 25 Newton. Right? Okay, and I think you have understood up to this. So here there are 4 forces but 2 unknown. So by this, once again resolving it sigma h, the same story, sigma h, sigma v, you will get 2 unknowns like what you're seeing on the screen. Okay, now how to solve this one? Here you are having RC, RB, and the second equation RB. So by solving, equating this, bringing this RB one side, we can find out the value of RB from the equation sigma v, that second equation. Okay, by that we can get the value of RB, and RB will be equal to 72.17 Newton. 72.17 Newton. Hope you understood, all of you. And next, let us move to the other values. The remaining things you have to find out the value of RC and RC value. So substituting this RB value in equation 1, so directly we can find out the value of RC as RC is equal to 57.73. Right? It's very simple, and you can find out by this method, you can find out all the unknown values and solve this problem. This is the the solution for this problem. Now I think we have touched in contact with your rollers having your single roller, and the 2 rollers are identical and it is slope. Now by having this knowledge, I am just going to give a task. The task is nothing but I am just going to give 3 identical rollers. Don't panic, it's very simple. You just work it out at home. You just practice it because everything is similar, and moreover it's very simple. I'll give you some explanation. So take down this question, and that will be the diagram which is given here. In this, all the 3 cylinders are identical, and note down the points whichever is more important, whatever I'm just going to say now, and then try to solve it. Okay, so now if you say that each cylinder is weighing 20 kilonewton because all the cylinders are identical, cylindrical pipes are identical, and with respect to its weight, diameter, everything. But it is rest on a rectangular U channel with a width of 160 centimeter. That is what it is given. Diameter is given and the length is 160 centimeter is given. So in order to make you confused there in the diagram itself, it's very obvious that one thing you have to notice, the distance between the length of a channel DG is 160 centimeter, but the diameter of the cylindrical pipe is 60 centimeter. So both the diameters comes only 120. It means that you should be very clear in that the cylindrical pipe A and B will not be in contact. Remember, unless and until cylinder AC will be in contact and BC will be in contact. So there will be a gap between A and B, and that is what to confuse you. They are given the diagram, and your free body diagram will be written like what you are seeing on the screen. Understood? So just you can make a note of it, and based on this, by using your trigonometric formulas, you can find out only minimum forces acting in cylinder 3, and you can get the solution for FCA, FCB or whatever it is. And one thing you should remember that in this case, if you are finding out the force of FCA, that will be equal to FAC, FCB and FBC. So it is more than sufficient that if you are able to find out the unknown values between two cylindrical pipes, that will give the solution for the other one also. So you need not find out. So similarly, in that case, you have to find out the forces acting with respect to the cylindrical pipe 3 as well as 1. That is more than sufficient that since both are, you can write the answer as since both are, all the three cylinders are identical, the one, whatever the answer you have got for 1, that will be remaining same for the 2 also. That is RD will be equal to RG and RE will be equal to RF. So that's the solution you have to write at the final. So before that, since there are 3 forces, you have to take the free body diagram for cylinder 3 and then get the solution, and then go for the free body diagram for the cylinder 1 and find out all these forces here and get the solution. These two cylinder, when you're resolving it, that is more than sufficient to find this answer. Okay, that's all about this cylindrical problem and the part 2, and I am concluding with the part 2 for this session. Thank you. I'll meet you in the third session.